In this video, I want to talk about kinematic graphs. All that means is graphs that describe movement. Now you'll be familiar with one sort already. We've got time on the x-axis and distance on the y-axis. So this is known as a distance time graph. Now the other sort of kinematic graph still has time on the x-axis, but it has something called velocity on the y-axis. Now for the purposes of this video only, I would like you to regard velocity as being the same as speed. It's not strictly true. Velocity has got a direction, whereas speed does not. But for the purposes of these videos, please regard it as the same. Right, so here we have a distance and time graph. This is in seconds, this is in meters. Doesn't have to be. This, for example, could be hours, and this can be in kilometers. Right, what can you say is happening after 2 seconds? Well, hopefully you said that the object has travelled 10 meters. Contrast this with our velocity time graph. Now remember, velocity, we'll regard that as being the same as speed. What's happening after 2 seconds here? Now this is also pointing at 10, but what we can say is after 2 seconds, the object is travelling at 10 meters per second. What's happening with this flat part here on the time and distance graph? Well, the time is increasing. It's gone from 4 seconds all the way up to 12 seconds, but the distance the object is travelling has stayed the same. It stayed at 20 meters. So this flat part here represents the object not moving. Time is passing, but the object, the distance from the start, is staying the same. Contrast it with the other one. What's happening with this flat part? Well, time is still increasing from 4 to 12 seconds, but the speed is staying the same. The speed is at 20 meters per second. So all we can say about the flat part here is that the speed is 20 meters per second. In other words, the speed is not changing. What can we say about this slope here? The distance is gradually increasing. So what we can say here is from the start at 0 seconds, in 4 seconds we've travelled 20 meters. What we can say about this slope here is we've got to 20 meters and the distance to the origin or to the beginning is gradually decreasing. So we're back to our start. Contrast it with this one. This bit here, the time is increasing. As the time increases, the speed gradually increases. So at 2 seconds, I'm going at 10 meters per second, and at 4 seconds, I'm traveling at 20 meters per second. So this represents acceleration. Speed is gradually increasing. This one here, the speed is gradually decreasing. So I go from 20 meters per second all the way to 0 meters per second, or stopping. So to briefly summarize, we've got two sorts of graphs. They've both got time on the bottom. One's got distance, one's got velocity or speed. These slopes, this one represents that the distance is increasing. This one represents the speed is increasing. This slope here, so this flat part here, represents the distance is staying the same. In other words, the object is not travelling. Time is increasing, but the distance is staying the same. This one represents the velocity is staying the same. In other words, the speed is unchanged. And these slopes here, this one represents the distance is going back to the beginning, and this one represents that the speed is gradually decreasing.